So for question 1, calculate the probability that an individual age 45 survives within the next 10 years. So survive, you can imagine that the notation must be TPX. Now we have survival function. So we use in terms of survival function. So for the survival formula, we use Sx plus T over Sx. But now we have two functions where we have the first one is for the interval age from 0 to 50. And the second one, we have the function for the interval age from age 50 to 110. So the first question is for age 45. So we use the first function because 45 in the range of 0 to 50. So for A, it must be P45. So the T is 10 years. So don't get confused which T and H. So 45 within 10 years. So it already gives you in terms of T, in terms of period. So not in terms of age. So you take straight away 10 and put at the back as a T. If it's given 55, so you have to change to the T. And then the second one is you have to calculate the probability density function. What is probability density function? It is PDF. So PDF is the small PDF is the small f. The small f. And then the last one, you have to calculate the force of mortality. The force of mortality at age 60. So at age 60, you have to use the second function since the interval age in the second function. And then age 60, what is the force of mortality for the notation for the force of mortality? It is mu x. So you have to refer back to your notes. What is the formula for the force of mortality? It is PDF divide with Sx plus T, isn't it? Sx. Am I correct? Anyone? Am I correct? Is it the formula for force of mortality? So for the PDF, you can get from the big F, whether you integrate the big F, you integrate, you differentiate the big F, or you also can differentiate as X, but you have to put the negative. Okay, the information that we have here is in terms of SX. So you can change into the big F and then you differentiate the big F, or you can also straight away differentiate the SX. Okay, for question 1, A is P4510. So since you are given in terms of survival function rather than actuarial notation, so you have to use this formula as x plus t over Sx, which is x plus t is 55 over S45. And then you plug in the function. So the 55 will use the second notation. So I put straight away the x inside the function. And then 45 will use the first notation since it's in the range of 0 to 50, and you will get 0.723. Okay, so the decimal point must be in 4 decimal point. So I will so it's about 0.7002. Okay, for B is small f. So since you are given in terms of SX, so we can straight away differentiate the SX. So the X is equal to, okay, so we are not given the X. So you have to differentiate for both function. So for the first one is you differentiate the first one 1 minus x over 150 dx. So you will get 1, so the constant becomes 0. So 1 over 150. So negative is positive. This is for x range x to 50. And then the second one, we take the second function is 1 minus dx. So you will get, okay, so positive, negative, positive 2x over 120. So we cancel it out. It becomes x over 60 for the range age 50 to 110. So this is how you should answer this question. So for C is mu 60. So mu 60, you have to differentiate fx60 over sx, and you will get, so fx60 is for this range, x over 60. So x over 60 over the sx is, straight away we take from the question. So we plug in the age inside. And we will get 1.333. So cause of mortality is not the probability. So the answer can be greater than 1. Okay, settle for question 1. Do you have any problem so far? Do you have any problem so far? Okay, so for question 2. Question 2, you are given select table and also ultimate life table. So select table for those for the group that are selected, which is already the group that went through the medical examination before they purchase the life insurance. However, the ultimate life table is the group, okay, for those who already selected for the select life table. So they have certain period. Let's say in this case, they have 3 years. So their medical examination only valid for 3 years. So after 3 years, they will categorize into ultimate life table, where is not selected or anymore, just from population. Okay, so after 3 years, they become, if they do not renew the medical examination, so they will categorize into ultimate life table. So the first year, the first 3 years, they are still in the select group. Starting from here, they will go to the normal normal life table, where we call it as ultimate life table. So for person who current age is 50 now, so at age 53, if he doesn't renew the medical examination, so he will be join the group of ultimate life table. Okay, first of all, okay, after you already understand what's the what kind of the table is, so then you can answer the question. So the probability that an individual selected for life insurance. So the key word here is selected. So you know that it comes from select life table, selected group at age 54. So the current, he passed the medical examination and he joined the select life table at age 54. So it will expire at age 50, 57. Okay, starting from age 57, it will join the ultimate life table. So the probability that individual selected for life insurance policy at age 54 will survive. So this is the keyword here, will survive for 2 years. For 2 years. So we draw the timeline. So now he is 54. So 2 years, 1, 2, meaning that until 56. So 56 is still in the selected group. So it is P. This is how you write the notation for select life table. So P54 in the square bracket, don't sum up, okay? But you have to put the current age in the bracket first, and then you sum up, okay? So P54, so T is equal to 2. Okay. This is the notation for the first one. Okay, the second one, the probability that individual selected for life insurance policy. So we know that it is from select group at age 51. So it start join the select group at age 51. Okay, so we'll die between age 55 and 56. So this we have to use conditional probability, where current age is 51, but we interested only, or we focus only the probability at age 55 and 56. I believe that you already know how to draw the timeline. So now he is 51. So the current age that he joined the life table is at age 51. But we are interested to know the probability that he will die between age 55 and 56. 55 and 56. So how many years to go to 55? So 52, 53, 54. So we have how many years here? 1, 2, 3, 4. So 4 years before the period that we interested on is already out from the select life table. So here now he is 51. So at 55, he will starting join the ultimate life table at age 54, meaning that at age 55 and 56, he already in the ultimate life table. So, you know that the notation must be, for this case, Q, because we are interested on the death probability, but he has to live. He has to survive for the first 4 years. For the first 4 years, he has to live. So age 51, the current age 51, and he will live at the first 4 years. And we just interested the probability from 55 to 56, where the T here is the T from 51, 55 to 56 is 1 year. So we're supposed to write here 1, but as I already mentioned for you, 1, we normally do not write 1 if the T is or S is equal to 1, so we don't put 1. So we just leave it blank here. We know that it is 1. So we have to find this probability. Okay, so the third one, we have to find the probability of death for the selected individual at age 50 plus 0.25. So the 0.25 is the fractional age. Remember, I told you the fractional age, we have point at the back. But in the life table, we don't have that such age. We only have like age 50, 51, 52. We don't have the age of 50.1, 50.25. So we need to use the assumption to solve this problem. So we have 3 assumptions. We have UDD, we have constant force, and the last one, we have Baldacci. But for this question, we have to use uniform distribution of death, or we call it as UDD, to solve this problem. So you have to use UDD assumption to solve for C. So now we try to solve this one. Question 2. Question 2. The first one is we have to find P54. Don't forget the bracket, because it represents the life and the selected life table. If you don't put the bracket, so it means that it in from the normal or from the ultimate life table, and it's wrong. Okay, so for the first 2 years, still in the life table. So this is the step how you have how you write down in terms of LX, in terms of the number of survive. So you don't sum up a 56, but you have to put as 54 first, because we know that it joined the select life table starting from 54, and then you plus 2. Don't write 56 straight away, but you have to write down like this. So because the TPX is equal to LX plus T over LX. So not for normal or for ultimate life table, just straight away sum up 54 plus 2 become L56. But for the select life table, we have to we cannot put it together. So 54 must be in the bracket. So over L54. Okay, L54. So L54 plus 2, when we refer to the table, L54 plus 2. So now we have L54 So L54 is here. So L54 plus 2 is 71,000. So it's still in the select life table, still in the duration for the first 3 years. 76,000. So you will get 0.9342. So it's logic because the probability of survive must